dumped, leaching deep into the ground, fouling the rivers and the groundwater. With London 2012's promise of urban regeneration, the soil beneath the Olympic Park had to be cleansed of its polluted past. Civil engineer Safina Sharif faced this enormous challenge.
We had fertiliser factories, chemical works, even an old landfill site. So there were a variety of different contaminants within the ground. Now, it would have been very easy to have just dug up the material and sent it to landfill, but in the times that we live in now, that's just not acceptable. London 2012 set a really ambitious target of 80% reuse of earthworks. So looking at how we could best reuse the material was our challenge.
Two million tons of earth had to be decontaminated. It would be the largest soil cleanup ever attempted in Britain.
I'm actually a Londoner myself, so it's quite close to my heart, this project. The work that we're doing here isn't just for the games.
Gigantic soil washing machines eradicated the contamination. Almost every polluted grain had to be cleaned. Claire Staveley was in charge of operations.
The site, because of its past uses, has various contaminants in it, such as heavy metals, arsenic and lead, mercury, zinc and copper. There's also hydrocarbons from oil tank leaks. You're trying to stop this entering into the human and the animal and the plant life.
To stand any chance of cleaning all the soil in time, the team had to keep an incredible pace.
We start work at 7 o'clock in the morning every day, and we finish work at 7 o'clock every night. We work Mondays, Tuesday, Wednesday, Thursday, Friday, Saturday and Sunday.
The soil washers took in dirty soil. The sand and gravel were separated by size and rinsed to extract the pollutants. Huge electromagnets stripped out scrap metal. The soil underwent rigorous testing in a laboratory to assess its health. For the team, awaiting the results was often an anxious time.
You have to wait and see what the results are like. Pester the labs a lot to get turnarounds on that, but it's very exciting when it comes through and it actually is clean enough to be used at a point where you could literally stick your hand in and have a little kitty swallow it and it wouldn't be a problem.
Instead of millions of tons, only a fraction of contaminated soil had to be sent to landfill. And mounds of clean earth could be transported for use on site. Some may have thought attempting to reuse 80% of the soil was impossible. But for Safina, reaching 85% reuse had made it all worthwhile.
We've actually managed to do better than has been done before. So we've set the bar and shown all projects, actually this can be achieved.
By September 2007, 90% of the buildings had been demolished. But with the opening ceremony now less than 4 years away, London, along with the world's press, eagerly awaited the design of the first sports venue to be built, the Olympic Stadium. The park needed an 80,000-seat venue, but it had to avoid a common problem. After the Olympic crowds had dispersed, nobody wanted an oversized arena. So London 2012 set architect Rod Sheard an astonishing brief. Ignore the rules of stadium architecture entirely. Embrace the temporary.
All the great architectural monuments of the world are all been there for hundreds of years, and it was a principle of forgetting all of those long-standing icons. A brief that was so fundamentally different to anything an architect had attempted before.
The brief called for a sole-use athletics venue, but its design had to be driven by its life after the games.
Problem is, of course, track and field doesn't attract 80,000 spectators, but it can maintain a 25,000 seat stadium.
Rod and his team had to develop a flexible venue. And after months of brainstorming, they hit on a radical solution. Below ground, a permanent concrete bowl would contain a crowd of 25,000. Whilst above, a lightweight steel ring would hold 55,000 seats for the Olympic Games. This entire top section could be later dismantled to provide a smaller venue if required.
It took us about 6 months being able to recognise that temporary has a beauty of its own. It's a light building, it touches the earth lightly.
But no sooner had the first design challenge been solved, then another quickly arose. Project manager Ian Crockford discovered wind conditions on site were a problem.
We started to appreciate, actually working on site, you could start to feel the wind. You've opened up a new corridor in London, straight up from the River Thames, and you could feel, literally feel the wind.
The stadium had been designed without a roof to limit steel usage. But an open roof would create turbulent wind conditions on the racetrack that could help or hinder athletes.
Can you imagine building a structure for the Olympic Games and then finding out that the wind speeds in the bowl exceeded any guidelines and no athlete was going to get a world record? I mean, it was absolute no-no.
London 2012 needed a record-breaking stadium. So Ian called upon structural engineer Fergus McCormick to investigate the effects of wind.
We built a computer model of the stadium environment and then had 3 models, one with no roof, one with complete covering over all the seats, and one with a partial covering. We could then set the analyses running with these different situations.
And you'll begin to have completely different sets of...
The results that came through were clear.